Hi everyone. In this video, I'm going to explain about the implementation of a combinational logic function using multiplexer. In the previous videos, as I discussed the implementation of a combinational logic function using decoder, the similar way we are going to implement any type of logical function or Boolean expression that we can implement using multiplexer. Suppose the given question was use a multiplexer to implement the logic function f is equal to a XOR b XOR c. So now you are going to implement this function f a XOR b XOR c. By seeing this expression, we can understand that how many inputs are there? Three inputs are there. One thing we need to remember that when we are going to implement a logic function using Boolean expression or any type of suppose something like that, it will also give in a similar way summation of m of something, it will give in this way also. F of a comma b comma c is equal to summation of m of like this. So you may be asked to implement a function Boolean expression will be given, or it may be given like a min terms list. Okay, f of a b c is equal to summation of m of, okay, we already know the meaning of this one is minterms. Okay, so that means you may be given with a list of minterms or it may be given in the expression, so you are going to ask with to implement using mux. If you read this line, you are going to implement with multiplexer, but the size is not mentioned. Size is not mentioned. You have to clearly understand this question. Okay, size is not mentioned. What do you mean by size? Generally, multiplexer is available in the size of 2 power n by 1 with n selection lines. With n selection lines. So 2 power n by 1, 2 power n by 1. Here, what is the size of n is not mentioned here. What is the size of 2 power n is not at all given here. So for that, you have to take the a comma b comma c or selection lines for such type of questions. When you are going to implement using multiplexer, you must consider the expression consisting of a combination of selection lines. Okay, so the selection lines are a b c in our given question. So how many selection lines are there? Three selection lines are there. So three selection lines will give 2 power 3 is nothing but 8. So therefore the multiplexer must be considered 8 by 1 multiplexer. 8 by 1 multiplexer. Okay, first you need to choose what type of multiplexer it is, what is the size of multiplexer it is. Without knowing the size, we cannot move forward. Okay, okay, this question is very clear. Okay, in the after this I will tell one more question where it is not clear and sometimes it is very difficult to identify how many number of selection lines are there and how many number of inputs must be there for the multiplexer. That type of question I will tell in the after completion of this one. Okay, now the given question is f is equal to a XOR b XOR c. So let us go with the truth table. Okay, selection lines a b c and this is f. So let us draw the truth table. 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and triple 1. So a XOR b XOR c. We know the XOR operation between three variables and it is 1 1 0. So 0 1 1 0 and 1. This is 0 0 and 1. Okay, so these are the selection lines. Like you can take it as S2 S1 S0 and this is the output function f or y. Okay, now we know for three inputs of selection lines, it gives eight outputs in inputs, eight inputs. Those eight inputs which are being selected in the output as D0, D1, D2. We know the basic and standard truth table of 8 by 1 multiplexer. D3, D4, D5, D6, D7. That means when selection lines are all zeros, D naught pin is highlighted. D naught pin is selected and will be sent to the output. Whatever the data that D naught has, that will be displayed in the output. Okay, if D naught consisting of 0, 0 is the output. Okay, and the decimal number, if it is 1, selection lines are 1, 0, 0, 1, then D1 pin is selected and sent to the output. So D1 pin is selected means what should the D1 possess now? It should possess 1. And similarly D2 should possess 1, 2, 1, and D3 should possess 0. So like that, when you are going to implement a multiplexer 8 by 1 with such type of AXR, BXR, C, D0 should connect with 0, D1 should connect with 1, D2 should connect with 1, like that D7 is connected to 1. Okay, in this way if you design, then this function will create a XOR, AXR, BXR, C operation. So the logic diagram is, so we have to take 8 by 1 multiplexer, 8 by 1 mux, D0, D1, D2, D3, D4, D5, D6, D7, D0, D1, D2, D3, D4, D5, D6 and D7. So 0 to 7, total 8 inputs with 3 selection lines. Those selection lines are treated as A, B, C. For our understanding it is ABC, but in the multiplexer point of view they are S2, S1, S0, and only one output function, that will be Y. Here for our output is F is equal to A XOR B XOR C. That means whatever the logic function we are getting from the multiplexer, that is in terms of selection lines. Now go to the truth table. D naught is connected to 0. So what are the terms connected to 0 now? What are the terms connected to 1? So F is equal to, we can write it as summation of M of which are ones. First pin is 1, second pin is 1, and fourth pin is 1, and similarly seventh pin is 1. So 1, 2, 4, 7. 1, 2, 4, 7. These 4 pins must be connected to logic 1 and remaining pins connected to ground. 1, 2, 4, 7. So 1, 2, 4, 7. These pins are connected to 1. These pins are connected to 1. Or we can say plus VCC. And the remaining pins are connected to logic 0. Okay, wherever I have taken the dot, that is connected, this is connected to 0 or ground. Hope you understand how to implement a Boolean function or a logic function using this multiplexer. Okay, simply when you have identified this particular expression f is equal to summation of m of set of minterms, simply the set of minterms which are there in this summation must be connected to logic high and remaining pins are zeros. Suppose if any expression is given like this example, f is equal to ax or bx or c, then you cannot directly write this expression, write this set of minterms. Then you have to use the truth table. So with the help of truth table, wherever you are getting ones, that you can write in the set of list, and then you can implement the Boolean, implement the multiplexer design. Okay. Now, let me tell you one more important problem where multiplexer size is mentioned. See here in the previous example, multiplexer size is not mentioned, but now multiplexer size is mentioned. So use 4 by 1 mux to implement use 4 by 1 mux to implement the logic function f of a comma b comma c is equal to summation of m of 1, 2, 4 and 7. 1, 2, 4 and 7. Okay, see here. Use 4 by 1 mux. You have to use 4 by 1 mux. How many selection lines are there? So 4 by 1 mux means you can write it as 2 power 2 by 1. So how many selection lines are there? 2 selection lines are there. 2 selection lines are there. And only 4 inputs are there. Okay. So now this 4 by 1 multiplexer has to implement the logic function f of a comma b comma c summation of 1, 2, 4, 7. In the previous example also you might have got the same 1, 2, 4, 7, right? 1, 2, 4, 7. Here also we have got the 1, 2, 4, 7, but there we have implemented the logic function using 8 by 1 multiplexer because three selection lines are there. A, B, C are the selection lines. So when three selection lines are there, 2 power 3 gives you 8 inputs. So that is sufficient there. But now the condition is you have to implement that the same logic function using 4 by 1 multiplexer. How it is possible to implement that three selection lines with 4 by 1 multiplexer? This is the important design. Okay, students may be having confusion in the implementation of this particular logic functions 4 by 1 multiplexer for three selection lines. When it is directly given, like when it is not given, that is easy because in our hands we can select how many number of inputs and how many number of selection lines. But when we don't have this particular concept, when we have this in size of the multiplexer, it is very difficult. Okay, let me first take you the same truth table whatever we have taken. See, everything is comes from the truth table only. Now the reverse operation, already the table contents are given. So A, B, C, and now we have output F 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. So we have 1, 2, 4 and 7. Remaining are zeros. Okay. Now how many selection lines are there for our 4 by 1 multiplexer? For our 4 by 1 multiplexer, 2 selection lines must be there. So those 2 selection lines, I am taking them as these 2 selection lines. Okay, I am taking S0, S1 as A and B. I am not considering C as a selection line. C will be one of the inputs. Okay, remember, C will be one of the inputs. Then only it is possible to implement 4 by 1 multiplexer with this ABC as inputs. Okay, so it's S not S1 means BA. So this is one set because A and B both are zeros, and A and B both are ones. This is another set, both are 0, 1. And again this is another set 1, 0, 1, 0. Again the last one is another set 1, 1, 1, 1. because selection lines must be a group. Selection lines S0, S1, S1, S0, both are zeros here. See the output F is equal to this one, same. Here whatever we have, here also same. Here also 1 means 1. That means when selection lines are zeros, output is nothing but F is equal to C. Listen carefully, this is very important. When selection lines are zeros, output is same as C. So that's why F is equal to C. And in this, when selection lines are 0, 1, output is equal to complement of this one. C. F is nothing but C bar. F is equal to C bar. And coming to this one, when selection lines are 1, 0, here F is equal to simply 1, 2, 4, 7, right? Okay. F is equal to simply, it is also C bar. And now here it is F is equal to C. Okay. See, now we have got the output function F in terms of C. Output function F in terms of C. That means here when inputs are 0, 0, the D0 pin must be connected to C. And D1 pin must be connected to C bar. D2 pin must be connected to C bar and D3 pin must be connected to C. Okay, so logic diagram. It is 4 by 1 max. Two selection lines are there. S1, S0. Those two selection lines are AB in our case. And D0, D1, D2, D3, D0, D1, D2, D3. So D0, D3. These two are C. I'm taking C, D0, D3, and this is complement of this one. That's it. This is the output F. So one of the selection lines we are connecting it as input, then we can make 8 by 1 multiplexer with 4 by 1 multiplexer. This is very important design. Okay, thank you.